And it was just, yeah, it was kind of, I was thinking that was very much possible. Like, I think really understanding the definitions.
Okay, so is that just not on me? Okay, how did you like the article?
Didn't.
Why not?
I don't know.
It's really, really important for this class.
It was long and confusing, and
Oh, well, but I cut off the first part.
we came to a consensus at this table that we're not even still sure what didactic is.
Oh, good.
So,
Okay, good. We'll talk about it.
Yeah.
I mean, not good that you didn't.
Yeah. Right. Yes. Yeah.
So, others, did you like the article? So it's really, really important for this class, okay? It's kind of frames the way we think about teaching with visuals, okay, or visualizations. So what was the dictionary definition of the word didactic? In your own, so dictionary definition, but then in your own words. What does the dictionary say? You're reading, Oscar.
According to Webster. Also, these are my answers that I wrote. I wrote it, so it says, according to Webster, designed or intended to teach people something.
Okay. Designed or intended to teach people something. Any other variations on that? Yeah.
There were also definitions that said it was used to teach someone something in an annoying way or in an unwanted way.
Oh.
Or patronizing way.
Oh, interesting. Okay.
Something else I found said having moral instruction as an ulterior motive. And I didn't think a lot of these definitions had anything to do with what the article
And that's the
said.
point of the
And then
next
I got
question,
really
right?
confused. 'Cause I
Any
felt like I
other
didn't understand.
variations that you want to see? This is getting interesting now. Any other variations you want to? Did you have something to add?
Yeah, just that mine was intended for instruction.
Intended for instruction. Okay. All right. So then, now we're talking about didactic objects. So how does the authors use the word, right? So what is it about a didactic object that makes it didactic? Angela, is it Angela?
Yeah.
Okay.
Its ability to start instructional conversation about conceptual ideas about mathematics.
Okay. Anything to add, Morgan?
Well, he said like 4 times that the object is not inherently didactic. It's
Right.
how the teacher approaches it that makes it didactic.
Right, and it's okay. So it's not how it's not that it's a poster or not a poster, or an animation or not an animation. It's about how the teacher uses it. And so, and Angela hit on how does the teacher use it. So, what is it about the way the teacher uses it that makes it didactic? Somebody else. Angela just pretty much got it, but I just wanted to hear someone else chime in. Not sure, or, yeah.
It's the conversations that they have around the object so that they can construct some kind of meaning or idea.
Perfect, right, and that's the same thing Angela said. So it makes it a didactic object if the instructor has some conversation, an intended conversation, or a conversation that's intended to teach something, right? Or build meaning for students, okay? So that's the point, that it's didactic if there's some kind of activity or conversation revolving around it where the instructor has a goal to teach something or build meaning within the students. Okay, that's what we want. Okay, so then what kind of examples did you come up for legitimate use of a visualization that's not didactic? So did you come up with some examples of that? Yeah, Lauren.
Well, when it says legitimate, does that mean like it doesn't have to be a bad thing?
Right, exactly. Yeah, so if it's not didactic, it doesn't make it bad. It's just you're not using it in that way. Yeah.
So I said like if a class is learning about volume,
Okay.
the teacher could display the figure that they would be finding the volume of, and it would just help create a visual of what they're doing instead of just playing in numbers.
Perfect, right? So you're just getting a visual, some kind of visual that just illuminates what they're doing, right? And there's no conversation about it, right? Other examples.
In my intern class, my teacher, she used chips like black and white shapes for integers. Without the conversation between the students, like what each one represents, it just becomes like just a visual for them to see like how to add integers.
Okay, so then are they using them in developing meaning?
Yeah, that's what they used it for. What I'm saying, if they didn't develop the meaning behind it.
So that's kind of in between. It's kind of in between. So if it's something they're using, they're actually learning and building meaning from the object. That's more didactic than not. So other examples.
Would it be like just having the unit circle on the wall? It's just there and present, students can use it.
Right. So then they're doing problems and then they're referencing that to answer certain questions. Perfect. Unit circle on the wall. Any other examples?
Just to like explain the graph of a function, and, like the functions they're doing, like they're not talking about it or the properties of it.
Right. Did I show you Clara the cow?
Yeah.
I'm going to show you again. So in my Calc 2 class, they have this project. And here's the project. No, not that. Not building this file. So, Clara the cow is, sorry, I think it's happening at once here. Okay, Clara the cow has been tied to a radius of 2 meters. The rope is attached to the westernmost spot of the silo. The rope is getting just long enough to reach the eastern point. Find the parametric equations for the path the cow can travel around the silo by always keeping the rope completely taut. Okay, so this description has everything you need to get started and solve the problem. Okay. But do you think maybe this would be helpful for understanding the problem? Seeing it? Extremely, right? Extremely helpful to make sense of the task that's being put before them. So I show this to them in class. Okay? And then they're off and running on figuring out what the equation of this pink boundary is of where the cow can graze. Didactic object? Am I using it? So, is it a didactic object? It depends on how I'm using it. Am I using it in a didactic way? No. I'm just helping them just visualize what their task is. So, if I'm not using it to teach about parametric functions, if I don't have some conversation that is intended to help them understand parametric equations or equations of circles or whatever I'm dealing with. I'm just illuminating what the project is, so to get a visual of it, an image of it, I'm not using it as a didactic object. Okay, so does that make sense? Okay, and your guys' examples were good too. All right, what's the next question? Last question. Okay, so the first day of class. I kind of forgotten what I did again. Same bolt and the marble falling. Okay. So, did you say they were all didactic or none were didactic, or what did you think? What did you think about the visualizations that I used on that first day? Yeah, Joey?
I said that they were both didactic, but the marble one was only didactic after we started talking about it and explaining it. Because at first you kind of just told us to look at it and make in our own head I forgot exactly what the video was about, but you tried to make us visualize it in our own head and solve it by ourselves.
Okay, so you guys agree with that? So the falling marbles visualization was not didactic, or was?
I have a question.
Yeah.
Because yes, we talked, but the talk is not always. I think that talk was more computational.
Okay.
And so I said it wasn't didactic because the talk we had wasn't very useful. So is that wrong to say that? Because just we have a talk doesn't mean it's a good talk, so it doesn't mean that like the didactic thing is a good thing.
Yeah. So I forgot how class went, but if I'm like I'm the progression of using that that animation. So if I just showed you the animation and then you were just using it as a visual to help you solve this question of what speed are we going to pick, it's really not didactic. It's really not didactic. But there's, so there's gray area. So we're seeing this with some examples where there's some gray area, right? So, I mean, we know for sure it's didactic if the teacher plans a conversation around the thing with the students around what this object is in order to teach something. But there's kind of, we've seen a few examples where there's a little gray area. Yeah?
So if the teacher doesn't have like a specific conversation in mind, but a conversation happens around something, does that make it didactic? Is it like the planning or the conversation?
Okay, great question. What do you guys think?
Well, that was also confusing because in the article it said that you could plan a conversation and it could completely do something else that you didn't expect and that was still okay. So I would say that yes, as long as there's some meaningful conversation.
But you're saying there wasn't anything planned and a conversation ensued from it.
Oh.
Right? So that's slightly different.
That,
Yeah. Same.
So I think the object itself can still be didactic, but then they went on to talk about the didactic model,
Right.
and that would be your plan to use the didactic object.
Right.
So you didn't necessarily make a didactic model, but that object can still be didactic.
Yeah, that's a great answer. Does that make sense? So it wasn't didactic, to start with, and there was no model around, the conversation that was intended to have. But then, then some kind of meaningful conversation ensued, kind of spontaneously. So it became a didactic object. Yeah. Okay, let's talk specifically about the different examples in the article. What was the point of this? The first example had to do with the uncommon uses of common objects. What was the point of that example? What was the author getting at? Talking about like this use of a didactic object. Somebody new. Lauren says, yeah.
Looking at fractions through an additive and significant perspective.
Okay. And so what did the teacher intend to teach? What was the teacher trying to teach? Both of those?
Well, most students would probably initially think about it additively.
Okay.
Myself included, so probably trying to push them. Raise your hand when you see 5/3 of something.
Okay.
And allow them to discover the multiplicative properties for themselves.
All right, cool. So the intended conversation was to get students to conceive it multiplicatively. Lauren, do you want to?
Well, it just briefly mentioned too that they're using like a completely common object, like a circle, but it generates like this really big discussion about relationships between numbers.
Nice. So just the fact that it's just this, yeah, good. Very simple thing, but look at how much there's to talk about if framed in a certain way, right? If framed in a certain way, there's this huge discussion that can unfold. And that's kind of like what happened last time in class, remember? With the very simple question about distance to LA, right? I gave you a didactic object, and we had an hour conversation grappling with that, right? So there's a lot more than just 2-sentence problem that you answer in 5 minutes, right? Anything to add about this example? What was the next one? Shared meanings. Square region. So what was this about? What was the author getting at by using this example? Anybody remember?
The root of seeing problems and understanding the language and using that square as a didactic factor to try to find the average relation.
Okay. Okay. So the square was about them discovering meanings for average rate of change. Any more to add? about that? Yeah.
I think it kind of
Jenna.
started that way, but then it went on to say that they thought they had made a clear consensus, and then they had them write it down, and half of them couldn't even remember what they were talking about, and the other, I think it was 11 of them, said completely different things that were all somewhat wrong. And so to think you have a consensus, you don't really have a consensus most of the time.
Okay, so nice. Okay, Josh.
Yeah, I was gonna add on to that. Because one of the things I find interesting is when teachers claim agreement has been reached just off of like no disagreement, that's like a common mistake.
Right.
Between especially like that, like having a conversation with it is why didactic object is having that conversation around that.
Okay. So, but even with the conversation and everyone coming to like perceived consensus, right? Like, then they had individual students write their meanings down, and it was everything. It was all over the place, right? It was all over the board. Yeah.
Yeah, so that's basically what I was going to say was, like, they had this agreed upon meaning, but then, like, there was no consistency on any of their answers. And I think he later goes on to say, like, just because you have agreement and you have these didactic objects, like, it's not just going to take one object in a good conversation to, like, establish a consent, like a real consensus where everyone has a firm grasp.
Yeah, that's a really good point. So just because you used the object and you used it just as you intended, and you saw the light bulbs go off, it doesn't necessarily mean that you're done with that. It's all the students have that meaning. Okay, and so that's important to. It takes repetition, right? Repetition, practicing meanings. So not practicing procedures, but practicing actual meanings and practicing your understanding of something until it really sticks. So it may take 3, 4, or 5 didactic objects on the same topic. Yeah.
Well, I was going to say, we did this, like, you had us write about average rate of change, like why we thought it was important. And I don't remember if you actually asked us what it was, but you asked us about it, and then you had us write it down.
Yeah, so, okay, that's a little bit different because I wasn't asking for your meaning of average rate of change, but just why you thought it was important. So that's a little bit different. Yeah. Was there another example?
Yeah.
Oh. Okay, third example. What happened here? What was the point of this? Somebody knew. Somebody knew who hasn't spoken up yet. What was the point of the third example? The authors. Yeah, definitely.
So a lot of students, they don't see the two quantities on a graph at the x and y quantity as co-varying. And the students that said that the graph was going back in time, they were just following the graph. And they weren't seeing it as co-varying quantities.
Right.
So the instruction will need to create a didactic object to get those students to see those two quantities varying together.
Nice.
Students also get confused about lines on a graph being like a physical object instead of a collection of points.
Nice.
So that was with the 2 fingers was really helpful. Like those were all individual points along the graph, and the line itself was just those points, not its own object.
Very good. Nice. Other comments on the? Yeah.
Following is what he was saying, like he went on to say about that then led to another conversation about the points comprising a line, the line being composed of points, the reversibility of each way of thinking.
Cool. Yeah, so this is all about, did they use the phrase shape thinking in that? So have you heard of that before?
Yeah.
So this is a primary example of shape thinking, right? So students seeing graphs, interpreting graphs or creating graphs out of just a shape image of the situation and not seeing it as a covariation of 2 quantities and a set of points that reflects that, right? So this is Ferris wheel. Ferris's wheel, they go round and round, right? So the graph must look like it's going round and round, right? So shape thinking is a huge issue for students. Students will bring shape thinking to your classes in a big way. All right. Is there anything else? Was that the last thing was didactic models then? And then just to review again, what is a didactic model? What's the difference between a model and an object? Somebody knew. What's a didactic model? Anybody?
I mean, I've already talked, so.
Last chance for somebody new. Jacob's gonna steal your chance. Okay, Jacob.
The models are more intended for the instructors than the students. So that was the main distinction for me. They're helpful in presenting a lesson.
Okay.
And then the object is what we present to the student.
Okay. So helpful for the teacher in preparing. What is it? So what is the model? What do we mean by that when we say didactic model? Somebody new. So what did you get out of that? Kendall.
Was that the point where he was saying it uses, the goal is to feed the ideas of learning and instruction in the model?
Okay, right. Anyone want to say more? Jordan, Alex, Bianca, Sam, Thing. Give me.
They give examples. Just in my summary, I don't have like an example of.
So the model is what the teacher's plan to use it. It's basically what it comes down to. It's all the structure of what the teacher's going to do, the questions that the teacher's going to ask, the way that the model is going to be used, and the plan for the intended conversation and how it will teach the students, or how they'll gather the meaning from using the model. Okay.
So it's the way you make an object didactic?
Yeah, so it's the whole plan surrounding the model. So it's the whole plan for using the object. Yeah. But it's more than just a lesson plan. It's also about it's more like an internal thing. Like the way the teacher imagines the student's thinking will change as that plan is executed. Yeah. Okay. Any other comments?
In the end there, it did say that it's a disadvantage.
What's
because
it?
it's hard to support this kind of model with objectives, and I was kind of confused because, like, if you have something that you want them to learn, you can still put objectives into a didactic model, and so I thought that I didn't really understand why it wasn't supportive of objectives.
I have to read exactly what you're talking about again. So, and you also started with a lot of pronouns, so I didn't like when you said it, and so I didn't know what you meant by it.
Just towards the end of the article,
Right.
there was something about it's a disadvantage to use these because
What's it? Didactic objects?
just using the model.
Models.
The model is
There's-
disadvantageous because there's not an easy or clear way to outline objectives in them, but I didn't really agree with that. Maybe I just misread
So like
it.
is it saying it's too rigid? Like having a model is too rigid because there needs to
I
be.
thought it was saying it's not rigid enough. Like, because you can plan for this to happen, and if it doesn't happen, it's okay. But then how do you teach and test a standard if you didn't actually teach it?
How do you get to
Yeah,
that
how do
point?
you actually get there if the model just lets them go any which way they want to?
Okay, so let me read that again, and
Okay.
yeah. So
You could have just been.
that particular point, I don't remember very well. So to try to address that, let me take time to read it again, and if we want to keep talking, we can keep talking on another time. Okay, so certainly this is kind of this is all these animations that we're building. We're thinking about having the ability to build sophisticated animations that we can have a conversation around with our students. So the point of the class is that, or one major point of the class is that you can develop your skills in creating animations so that when you have something you intend to do, then you have the ability to create the animation that will support that, right? So and that takes time. So like for myself, it took me probably 2 or 3 years of playing with Graphing Calculator before I was really making the kinds of things that really supported what I wanted to do. So it takes time to learn it, right? It takes time. There's lots of things GC can do, and so we're kind of adding, little by little, we're adding to your repertoire of things. Okay, so let me show you it in action here. So this file okay, so I'm gonna talk about it for a second here, and if you've got some work on it, if you can not have it visible to other students. So what this does is it allows you to define in the first line what are called the breakpoints. So the breakpoints are X values where the rate of change changes. So they'll become corner points on the graph, the X values of the corner points. And then the rates. And so rate 1 would be, it's always this for this particular one, I'll start at X equals 0. So rate 1 will apply from X equals 0 to breakpoint 1. And then rate 2 will apply from breakpoint 1 to breakpoint 2, etc. So then rate 3 applies from breakpoint 3 to breakpoint 4, and then, let's see, does that make sense? Did I say that wrong? I think I got one off, but you get the idea. But the first rate is always from X equals 0 to breakpoint 1, and then each rate then is for between the next 2 breakpoints. Okay, so what the file does is you can just come up here, and so now I want to change breakpoint 1 to 4, and breakpoint 2, we should make it greater than 4, so maybe 4.7. Breakpoint 3, 4.9, and the breakpoint 4 I'll leave at 5.7, and then I can change my rate. I can say -0.5. Rate 2 could be 2. Rate 3 could be 10. And then rate 4.1. That's great. And so now if I graph it, it will give you the new, it'll graph the function f of x with those breakpoints and those new rates. Okay? So there is one more command line that you have to come up with that does this. Okay? So one more command line that defines the function f. So that all you have to do is change these numbers and then hit graph, and it will graph the new f. It will graph the new f based on your breakpoints and your rates. Okay, so is the task in terms of what it should do, does that make sense? Okay, so let me show you how you can define piecewise functions. So if we say f equals, so on the explanation sheet for the task, it also explains this, that if you hit Control A after the equals, it will give you two pieces to your function, and then you can continue to hit Control A, and I'll just keep giving you more. Okay, so suppose for f of x, I want it to be 5. So what is it on PC?
Control Shift A.
Control Shift A is how you add, after you hit equals, how you add a new line. So suppose I want my function to be 5, and so I'm going to say if, and I want to say that x is between, say, -2 and 0, I guess. Okay, so when x is between -2 and 0, so let's make it, we need to have continuous, so less than or equal to 0. So when x is between 2 and 0, the function will assume the value of 5. And then maybe I want it to be x squared if x is between 0 and, say, 2, or 1.5. Okay, and then maybe then I want it to be -3x plus 7 if 1.5 is less than x is less than or equal to 4. So I'm just making this up just so you can see how it works. So you need to be if, not commas. Okay, so when you use these, when you define the ranges, you need to use if. And so I can just delete these. Yeah. Okay, so then I'll just make it 3 parts. And then is that going to graph the function? Nope, that just defines it. We know to graph it. If we want to show the displayed graph of all the points, y equals f of x. What happened to this? Oh, I still haven't gotten there yet? There it is. So here is my little piecewise function that I have defined. Joe, you have a question?
Yeah. Oh, wait, never mind. I'll talk about it.
You figured it out?
Yeah.
So that just gives you a little demonstration of piecewise function. Okay, now one more thing that you should know is, let's see if I do Control A, can I add one? Yeah. That you can use the function definition within the function itself. So I could say I want it to be f of -1, maybe. So 1/2 of f of -1 if where are we at now? 4. 4 is less than x is less than or equal to 6. So what's that going to do? So what's it going to do between 4 and 6? It's going to find what f of -1 is, which is what? 5. Take half of it, and so between 4 and 6 it will graph constant function of 2.5. Which just happened to be, was that actually what you get? And I didn't even intend that. And it ended up that it took over the, oh, no, I see. So what's it doing here? Okay, so what happened? Yeah, so how does GC plot displayed graphs? What does it do? What's that? Connects points, right? So it's going to get a bunch of points and it's going to connect the points. So how can I don't want this, right? There shouldn't be a vertical line. There's only one function value at 4, and what is the function value at 4? -5, right? -5, defined by this third line. There's only one function value at 4, which is 5, defined by the third line. So, and then as soon as we're greater than 4, we want the function value to be the 2.5, and we don't want this vertical line. So what can we do how can we change this so it displays what we intended to display? So this function is correct for what we intend, but it's not displaying what we intend to display. So we want to fudge this. How can we fudge our definition so that it actually displays what we mean it to display? So that's probably happening here on the y-axis too. I turn the graph off. So we don't want that, right? We don't want that.
Less than 4.
Yeah. Yeah, so it should work if we just what happened? Right. Why not? What's it doing? It's still connecting points, right? It's still connecting the point really, really close to 4 on this side to just less than 4 on this side to the point just greater than 4.
That's just bad.
What's that? So I don't immediately know how to fix this.
I put 4.1 into the one where we have f of x.
Yeah.
And it kind of worked, but it's obviously not ideal because then
Yeah, so the question is, how small can we make that and it'll still work?
yeah. It's not very small.
So 100th, that's pretty decent. We can't see that with our eye unless the difference between 4 and 4.01 with our eye. So that's one possible fix for that. But it highlights the point that what is a graph, right? What is a graph? GC creates it based on what it is, which is a set of points, and it can't graph all of them because the pixels on the screen are limiting. But then also all of them would be an infinite number of points. So it just takes a lot of points that are really close and connects the dots. Okay. So it just reiterates that a graph is a set of points, and that's the way that GC displays graphs as a set of points. But back to our original conversation, just getting used to piecewise functions and the fact that you can use the function definition within, now the problem within the definition. Now a problem comes if you do this. It's going to happen here. Yeah, so it's going to get stuck in a loop, right? So it's going to be undefined because it keeps wanting to go back to the previous line to define its value, and the value never gets defined, right? So can't do it, right? It can't graph for -2 to 0, and it can't graph from 4 to 6. You got to be careful about an undefined structure. If you're using the function to define the function, it's possible to get this endless loop, and so the function will be undefined, not defined. Okay, questions about just the basics of a piecewise function? Yes, thank you. Yeah.
Can you assign each line to a new function name? So the whole piecewise is f of x, the first one is g of x, and h of x.
Yeah, and then you have to define what g and h are in a different line. Yeah.
Okay.
Yeah, because you can make new function definitions out of old ones, like multiplying functions, or so that would just you could have different functions for each, and you have to define it. But in this project, you want to do it as one piecewise function for f. So one more command line using a piecewise function for this. So one more command line defining f piecewise based on the rates and breakpoints. So if you just change the rates and breakpoints, you get the graph. Did I answer your question?
Kind of. So then how would you, if your first line, you needed to use that in your second line recursive, how would you do that without naming it? Like,
So the point 0, 0 will always be on this graph in this. Does that help? So 0, 0 will always be. Yeah. So you can do it. It doesn't. It's not. Then what? Quick, but line 1 isn't referring to line 2. You want line 2 to refer to line 1. But line 1 isn't referring to line 2. That's where the problem comes in.
So can you use?
So so in your first line, you're not going to use anything that you're not going to use any. You can in the first line of the piecewise function, you should have no problem graphing that without using the function.
Right.
And then line 2, if you want to use what's something in line 1,
Yeah.
no
Then
problem.
just type it out again. You don't want us to use.
Type it out again.
I think it's hard to ask him.
Okay.
So, but it's you're not using the whole function definition. You're using a particular value from the function in a new line. Does that help answer it? Like what I did over here. So I'm not using. If I put f of x here, that just doesn't make sense. But I'm using a particular value that I've defined before. So if I go back to this, make it, what did I say, 5. Let's start over. And so, sometimes my experience has been if you put a line or some lines in, this is a side note, in a piecewise function, and it seems like everything's right, but it just doesn't work, just erase the line and type it again. Sometimes there's something that happens. Just erase the line and type it again. If you're absolutely 100% sure it's right, but it's not performing, erase it, write it again from left to right. Don't, if you're getting in there and editing parts in the middle, that can mess it up. Okay, so what did I have? -2. Okay, so I'm just using one point of the function. I'm just using the function value at -1 here, down here in this line. But this line doesn't refer to others. Anyone ask me later?
I suppose.
You want to try me one more time?
Say if line 2, g of x equals x squared.
You don't want to define, no, you're not to, not for this problem. Don't define new functions. I thought you were just asking that in general. Don't define new functions for f, because then you're going to have to define what g of x is on other lines, and that's not permitted.
So then if you wanted to use the value of x squared in the third line, would you just type out x squared again?
In the third line?
Yes.
If I could use x squared again, sure. I could use x squared again, or if I want a particular value of the function between 0 and 1.5 based on x squared, I could just use what f of 1 or f of 0.5 here. But if I want it to be, if I want this to be x squared again, sure, I could write x squared again.
And then if you wanted to use -3x plus 7 plus x squared in your fourth line, then you would just type out that entire thing again.
No, you would say f of and then whatever value in between.
You're confusing expressions with values of the function. So anyway, so yeah.
So like she was saying, what if I wanted to reference the third line in my fourth line, but I don't have a specific input value that I want to use. I just want to use something within that interval. Because like in this one, we're using BP1. We're not using like specific values. So do I reference just the endpoint? Like, would I say f of?
I don't agree with you. So you have a specific value that you need, and you can represent that specific value that you have and that you need. So this goes back to just understanding how functions work. What does function notation mean?
Well, and in this case of this one, it is a specific value, but we're using we're defining this variable. So you can't just say f of 4 because we want it to be able to change with how we change our breakpoints.
Okay, so
then how do you?
You're answering your own question. You're answering your own question. Okay, let's move on. Any other different questions about this?
Are the BP ones and stuff strings that you assign a variable?
Yes.
Or does it just know that
Remember, I think I showed you this, and yeah, so you need to, when you start this line, so I'll just do another one here. So if I want, say I wanted to do BP5 also, okay? So then I do comma. Remember how to do this. Backslash, true black, backslash, not forward slash, backslash, BP5, and then backslash again, and now that whole string is a single variable, or parameter, then a parameter, right? So, and then I would say equals whatever, 8. So remember backslash, then write whatever string you want. When you hit backslash again, it will make that whole thing a single variable, but you need that, right, for all these. Okay, other questions? Another project that's coming up here is what I showed you from, I'll show you Thursday. Okay, I'll just show you Thursday. So so you're going to finish up this one. You're going to start your work on the, oh, I haven't shown you that yet. Shoot.